So we're talking about this sheet that the flip group took home today, and like I told you in class, that's the only group that had homework tonight. The other group didn't, and that's just simply because it just worked out where I needed you guys to see this ahead of time. The other group doesn't really have anything they can really do tonight because we went to the computer lab today, but they will have homework one night when you don't. So it'll all work out. What I want to do before we get into two steps, because that's really where we want to be, is I want to just kind of warm up with a couple of one-step equations from this sheet, and then we'll go straight to the two steps. I'm writing with my mouse today instead of the pen I normally use, so it may be a little rough looking, even more so than usual. The other thing's not working for some reason, so I got to get that fixed. So let's look at this problem. I'll let you read it. Basically, it says he has R rocks. We don't have, it could be any number. We don't know right now, just R. And he's going to separate those R into 3 equal piles. So there are a lot of different strategies for solving problems. For me, this is a very visual problem. I could put an R and I could think, all right, well, I have 3 piles. So I'd put one in that pile, one in that pile, one in that pile, another one in that pile. Basically, I'm taking this R number of rocks and splitting them into the piles. So if there were 1, 2, 3, 4, 5, 6 rocks, well, there'd be 2 in each pile. Just split it up. Well, I can see that the operation that takes some number, like R, and splits it into different groups is division. I'm dividing it up. It's the only operation that does it. So what I'm looking for is R rocks divided into the 3 groups. And then it also tells me that leaves me with 12 rocks in each group. So this is what I'm looking for. Now, I know that there are other ways to show division, and this is one of them, so it looks like B is the correct choice. Let's talk about the next one. So she bought a sweater that cost D dollars. She gave the clerk $40 and received some change. So which equation represents the situation? So this is one of those where, you think about if you actually went to the store. Like this is, you sort of just reason through this. And one thing I will do is instead of D, like sometimes I'll pretend like D means something. Like I'll pretend like I already know what it is just to solve it. Now I don't know what D is, not until I've worked it out, but I'll pretend, like I'll say, well, if she paid $40, then it had to cost less than that, right? So just make up something for D. Like let's pretend it's $30. That's how much it cost. So we're just pretending like D is $30. So, imagine you go to the store, something costs $30, you give them a $40. How much change are you going to get back? $10. I think every one of you could have said that right. Well, how did you get it? Did you say 40 minus plus divide? You did 40 minus. You said $40 minus this 30, and that gave you the 10. Now, I know what you guys would be saying if you were in my class. You would be saying, oh, where did you get that 30? Once again, I just made it up. Like that's one of the strategies that you can do when you're dealing with variables is you just pretend for a second. Because now we're going to step back and say, all right, well, it wasn't 30. We made that up. Instead, it was D. So the only change I need to make is I need to say, well, $40. I don't subtract 30 because it wasn't 30. I subtract D. You take the amount you brought in minus what it cost, and that gives you your change. Now, the change wasn't 10. The change, it says, was $5.19. So once again, my strategy, and this is something you just have to really practice. Word problems are tough. You got to practice them. My strategy, though, was to just pretend like D was something that I knew, like $30, so that I could figure out what to do. And I figured out, oh, I would subtract. If D's 30, I know I subtract. Well, then I just go back and set it up as a subtraction problem with the numbers that they gave me. And then I can easily see that it is answer choice A. Now on to the two-step equations. So let's just use this space here. What I'd like you to do is either get a separate sheet of paper out or find just a small spot on your paper to write this down. So here's a two-step equation. We're not even going to solve this. I just want to talk about it. 3x plus 2. So 3x plus 2. We used a couple of words that were pretty important when we talked about these and what they meant. I think it was on a previous homework assignment. We said that this 2, the number without the variable, see if anyone can remember. Try to think of it to yourself for a second. what this number is without the variable. Hopefully you remember that's called a constant. Constant's a number without a variable. And then this is the coefficient, but what's really important is the constant. And if you don't know what constant is, you could have looked it up online somewhere. Constant means something that doesn't change. It's the same in any situation. It's a constant amount. It doesn't change. Whereas the variable is going up or down, depending on the number, the coefficient. So here's what that could mean in real life. Okay, so here's a situation that would be a two-step equation that's where constant is important in. So it said if you had a taxi company charges $2 for any trip, and there's an additional $3 per mile. So see if you can follow me here. We have a $2 that's just a constant rate. No matter what, you're going to pay $2. So if you get in that taxi and you go like one block, you just drive to the end of the building that you're sitting at, they're going to charge you $2 regardless. So that's a constant rate. Everyone pays it. Everyone pays the exact same constant amount of $2. So it's just added on. It doesn't matter how far you go, you're going to pay that $2. And so we get plus 2 here. Then there's a variable rate. And then that's the rate that goes up or down. In this case, we're paying $3 extra per mile. And we know per means to multiply. So $3 per the number of miles. So that's the part that's going up. So this two-step equation would represent this situation. And basically what you could do with this is you could say, well, let's say that we go 10 miles. So x equals 10. What you could do is you could say, well, we go $3 for every mile, so 3 times 10. And then everyone pays this $2. That's our constant rate. So for our mileage, we're going to do $30. It's going to cost us that much, $30. And then we add on our constant rate of $2, and we end up paying $32 for our trip. So this is what you're looking for, and this is not easy to grasp. It's something that's going to take a lot of practice. So just know that these are two things you can look for, and you're going to get it eventually. So $2, so you have the constant and then the variable. So let's look at some of these word problems to see. Some of these word problems we'll be able to pick that out, and some we won't. So let's look at this one. This season, the number of points Reggie scored was 36 less than 4 times the number Larry scored. Reggie scored 64 points, the equation below. So they give you the equation. So this one, we really don't even need this because they gave us the equation anyways. So let's just look at it. So it looks like they're saying 36 less than, that's where they get the minus 36, 4 times the number Larry scored. So 4 times the number Larry scored, which was, and Reggie was 46. So if we look here, it said, what was the 4 multiplied by? Oh, the number Larry scored. So what does n represent? Larry's score. So that one's pretty easy. Let's get on to another one to see if we can use what we just talked about in a different problem. All right, I brought up the next 2 problems, and I did skip some. I meant to say that, try those 1 steps on your own. We'll go over them in class, but try to find your answer on your own the best you can. Let's go over 6 and 7 here. Jonas bought 3 books. Each book was the same price. So after using a $10 off coupon, the total charge was $20. So the first thing I'm going to look for is just my constant. What's not changing? What's the same thing that everyone could get? And it looks like, all right, no matter how many books he bought, he got $10 off. That's a constant rate. No matter, he could have bought 50 books, he would have gotten $10 off from the look of it, from the look of this problem. So now if it's $10 off, it looks like we would subtract 10. So I know I'm going to subtract 10 from whatever total I get, because that's our constant. The charge was $20, so I know that eventually I'm going to have equals 20, because was means equals. And then this looks like our variable. This looks like what we're going to multiply. He bought 3 books. So this is what's changing, because the more books he buys, the more he's going to spend. The fewer books, the less he's going to spend. So it's going to go up or down depending on, so that's what we call variable. It's changing. So if he buys 3 books, that would be, he needs to buy 3 times the number of books. So the cost of each book, 3 times the cost of each book. We take off our $10, we get 20. That would be this. So the rate that's changing is how much we're paying for books. We're multiplying, and then we're taking off this $110 that wouldn't change no matter how many books we bought, and that would be our equation. All right, so let's look at number 7 here. let me get rid of this so we can work. And I'm glad 6 was on there because it really illustrated what I was wanting to talk to you about. We'll keep practicing that, and it's a skill that takes practice. It's not something you're going to be born with. It just takes lots of practice. The first thing you should do when you see a problem and it says a rectangle and you don't see a picture of a rectangle, the first thing you should do is draw a rectangle. It's easy and it's going to help you. So let's draw a rectangle, and then we're going to start labeling it. So it says it's x centimeters is its length. So what I'm going to do here is I'm going to go to the length and put x. Then the width, that is equal to half of its length. So let's see, it looks like they're doing half with a fraction, but they also do it with x over 2. So let's just do half of its length. To half means to divide by 2. So we're going to do x over 2. Let's just draw a fraction bar there. So what we have here is the length is x, this is half, so we divide it by 2. Now let's keep reading our problem. Let me find my pen here. The perimeter is 22.5 inches. Remember, is means equals, so let's go ahead and put equals 22.5. And we've talked about this, so most of you are pretty good. You know perimeter means you add all the sides. So let's add this side, x plus x over 2, plus, what's the side across from this? Well, it would also be x over 2. Once again, we're finding the perimeter, so we're adding all the sides. And then we have the length, which is x. And then the parallel side, which is also x. So we have this as our equation. So now just bear with me. The point was being able to write this. So you're pretty good if you can write it. Now let's simplify it and see what we get. If we have x over 2 plus x over 2, remember, for fractions, we just keep the denominator the same and add our numerators. What's 1x plus 1x? Oh, 2x. And 1x plus 1x is also 2x. Sorry this is taking so long. I'm using my mouse, like I said before. All right, let's put extend. And right here is where I may lose you. You know, please come in tomorrow and ask about this if you need me to, because it's going to be hard to explain this on the video. Basically, if I have a 2 here, though, and a 2 there, I can reduce my fraction by getting rid of the 2's, and that leaves me with just an x. That's if you ever have the same factor on top and bottom, you can do that. And that's probably pretty new to most of you, so I understand I'm probably going to have questions. That's good. Please ask them. So we have 1x plus 2x equals 22.5. 1x plus 2x is 3x equals 22.5. And just because it's so slow, what I'm going to do is I'm not going to show that division. I'm just going to use a calculator really fast to grab that. So we're going to do 22.5 divided by 3. It'd be good to put the divided by 3 on both sides here. It's really slow what I'm doing. And I got 7.5. Only way, it didn't say to do all that. Never do what I just did. I'm sorry. I get carried away with all this slow writing here, and I didn't even look at my answers. Always look back at your answers to make sure that you're doing it in a way that makes sense. So let's figure out which answer it would be. All right. And actually, I'm glad this happened because it's a good test-taking strategy to always look and see your answers before you do all this stuff. So if you look here, like when we got to this step, x plus 2x equals 20.5, we actually found one of the answers at that point. And from best I can tell, that would be the best answer. So I'm almost out of time here. This is tough. It's going to take practice. Please bring your questions, though. Let's discuss them and just work on this, and you'll get how to do this eventually.